This is Bob, LIGHTBOB from LIGHTBOB TV. Believe it or not, we are at episode 11. So that means it's about 11 weeks that I've been running this. I think we have 44 different episodes that are canned. Uh, it's just amazing. Thank you for watching. Thank you for being there. Thank you for giving me the platform to express myself and talk about things that I care and I like. And today, on this beautiful Wednesday, we're going to talk about 3D print material and their effects on lights from the manufacturing viewpoints. And again, as you saw, I take like a segment, let's say manufacturing, and I will look at different viewpoints and I will explore. Uh, Probably my goal is to reach 100 episode, and then make it. I will start to package it, put it in some kind of curriculum, and then you know rebrand it and start being my own training and courses. And what you're gonna hear from me and my viewpoint is also what you don't hear from other people. Some people are very technical, some people are very philosophical, some people are very artistic. I'm not. I'm not any of those. I have my own style. I like to freestyle. I give myself some parameter before the episode, and I go and I start to work on it and also develop as I go because I think some things are important, some things are not as important, uh, and and that's how I am because sometimes I think of something and I said, oh yeah, today we should talk about this, and then we should talk about that, we should talk about this, and then when I relook my episode, I'm like, oh, I take notes and I say, oh, I should have been talking about this, or in a future episode I should write this and I should write that. So yesterday we start this new series on 3D print, and as my specialty is lighting design, I thought I would bring you to the lighting community and the 3D print community. I would bring you my input because for over 15 years, I've been looking and trying and working with this additive manufacturing technology, but nothing was really standard, nothing was really set up or accessible, affordable. Anyway, we're in a very different position, and this world, including AI, is helping us to bring us to different level, which I think are more and more attainable because of this additive manufacturing technology that we're talking about. And as you may know or not, I've been involved in the different area of additive manufacturing, nanotechnology, uh, metal, all kinds of insulation, optical, uh, resin, name it. I touched it, even concrete. I did a big evolution on 3D printing for concrete. And again, when I was there, I was like, why don't we integrate this? Why don't we integrate that and this and that? And today, even today, they're not in. But there are things that could be integrated to 3D printing at different level, not only at the concrete or the metal or the resin or the filament, but this could coexist and start working together. And frankly, that's what I do when I meet manufacturers and I go and I visit. Like last week, I was in Texas and I had a chance to go talk to some company that I met before, and they just had the first machine in Texas that inject carbon fiber inside to give strength to PLA or any other materials so that you can get some real strength. So all of those technology and those technique and those machines and all of that are very nice and dandy, But if there's not a brain behind to control it, they're absolutely useless. And the best example I have for you is that even in my own lab with my own staff, it's very hard to achieve what I want to achieve. Even though I give clear instruction, I give clear prototype. When it's time to, everybody's got their two bits, everybody's got their grain of salt, everybody. And that's the one, I would say, one of the drawback of 3D printing is that once people start to have a little bit of knowledge, then they start to improvise and think that it's okay to do all kinds of weird stuff, which on the long run or on the vision of the project or the product, they don't have any idea what they're doing. So again, manufacturing side, it is a very fluid medium, and it's very easy to get upside out the track because you're depending on a lot of stuff. So today, the episode that I wanted to bring to you has nothing to do with the machine. It has to do when we start printing object or when we start thinking about an object. And yesterday we were talking about lighting fixtures, right? So what we're going to do is I want to go a little deeper because I told you we can shape and control the light. And I told you a little bit about the material, how the light behave on Monday. I told you a little bit about the material yesterday. But today we'll try to get a nice overview. So as a manufacturing viewpoint, you can have the idea and you can see that if it's something you want to do or you don't understand or you just want to have some concept, how you can integrate, there is room for gradient. There is room that you don't need to go from 0 to 100% 3D print. You can just start with little piece, little parts, little this, little that, and suddenly you will come to a conclusion and you'll come to a certain a certain arrangement of machine that produce exactly what you want to produce. If that makes sense, right? So let's start with the frame, right? Like when we talk about frame, I'm talking about what define the light or the fixtures, because as a manufacturers, not many of us are going to jump in and start manufacturer source. There's a few of them, they're doing a good job. I think it's easier to be integrator and take their component and their driver and then start to design cool stuff and make some beautiful frame. So one thing that is very stable is that light source, if you go to general diffuse or if you go to directional, they all have the same shape. So either you get the light all over the place or you get the light in one direction, okay? No matter what material you use, this is the basic. But now, depending on what material you use, you could have a series of different results. Meaning that, as we're going to see, if we use certain material compared to another, well, now we have a directional, but we have also some light that is coming from the side. If we have another material or we make opening on that side, we have light that are coming on that side. We have light that are not coming anywhere. So again, depending on the source we're using, directional or general diffuse, and the shape we're doing, and the material, now we can start adding layers to the way we're modeling and modulating light. And in some case, the material we use is not just for the structure. It's not just to hold our light there. It could act as a filter. It could act as a diffuser. It can act as a support for something else, right? Which with traditional fixture, it is a bit harder to do, and I'll tell you why. I'm a glass artist, and when you start to you want to diffuse light, glass is the best. So, except that glass, it's a very complicated medium to master. Unless you're molding and you have the setup and you are very good at it and you have a very good crew, repetition is also difficult. I mean, for yourself, I can go online and buy 100 pieces of that and they come and they're all the same. But I'm talking if I want to start manufacturing from A to Z. So in 3D printing, it's the opposite. I can do whatever I want and they'll be always the same. Always the same. Boom, 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 boom. So it gives me that freedom of creating anything I want and be able to repeat it. Now, what does it have to do with the material? Well, that's the same thing. It's now material are coming and that you use pellets, that you use powder, that you use filament. You have different manufacture, and then also they all have different variation. So, but this is not something that come instantly. You know, like when we used to buy a casting in metal, or they all come with the same material. We want an aluminum casting; it's all in aluminum. We want zinc or another metal. We had that casting, or we had a spinning, or we had a stamping, and that was very regular. Now, as we're talking 3D, we really have to be specific. And one thing I realized that I didn't do enough at the beginning is I was not documenting anything. I was not writing what filament, which one I like, which one I didn't like, which one, turned into a spaghetti, which one didn't turn into a spaghetti. I just went through a series of experience and never crossed my mind to document anything. And it could have been very, very simple. I could have just take a little notebook and, okay, this is a Sunlu filament, and how did it react? Good, and then, oh, this is another brand. This is another brand. And, oh, this one, doesn't stick to the plate. This one turned into that. This one, skip or shift or, clogged my nozzle. And this is what I want to tell you about. And because it is very real for me that I wish somebody would have told me that. I wish somebody in the lighting industry would have be a pioneer and tell me about the sources. I wish somebody in the industry would have told me that, depending what printer you buy, you have different quality. Some of them are more experimental, which I didn't know. And some of them are done for professional use. Also, the service. One thing I'm very, very impressed with all of them, because when I started, I didn't have much money and I didn't know if I would like it. So I bought a couple used printer and I got in touch with the manufacturer and I said, oh, I need a new screen, I need a new nozzle, I need this, I need that. And I would order all these parts. And I was surprised to find out that even if some of the printer I had in my farm when I started were discontinued, they still had the part. That blew my mind. And of course, the newer printer I bought, the new generation, the new all of this, now it's just like we're in constant. And I send them pictures of parts I do. I send them pictures of the mistake. I send them pictures. So we are back and forth, and I work very closely. And that's just at my level. Now we're going a little higher. We're looking at more sophisticated printer, and it's the same relationship. Before you talk to the machine, you talk to a person. You talk to a machine owner. You go, you ask, so do you like this machine? You go, what do you do with it? What's the problem? What's the most expensive parts that you had to replace? How long have you had this machine? So all of that is part of your new dialogue, and it's ongoing. And like LEDs were 20 years ago, 3D prints have done a beautiful evolution, but there is still room to improve. Let's come back to manufacturing. So the idea here, when we think about the product that we want to manufacture, is that we're not just printing a form or shape. We're printing something that's gonna change the light behavior or dictate the light behavior. It's it's you're commanding the light behavior, not vice versa. Not like what do I do and how do I do this. No, you understand how the light works, you understand how the machine works, and now you're commanding through. And how do we do that? Well, we have some material that let the light pass through very clearly, right? Very, very minimal diffusion. It's almost clear. And the idea is that you use that to make a protection. So you want to have as less restriction on your clear, so that, and then you're protecting whatever fixture. So if you're doing an outdoor fixtures, or you're doing something that may be affected by dust or something like that, you want to have something that has the maximum, you know, transparency, and then also has the minimum uh, re, re, restraint on the light, because you want to have your directional, and also something that will resist the 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 temperature, outdoor or inside. And what I meant inside is inside the fixture, because if you're enclosing a fixture, now it becomes a vessel, and maybe it's not affected by the exterior temperature, but it could be affected by the interior temperature. So what you want is something that, well, first of all, you're going to end up seeing the source. You're going to have probably very sharp shadow, and potentially a lot of glare, right? Because you see the LED directly. So again, if you're doing something outside, you need a source, you need to protect it, or in an environment that it's very contaminated, or dust, heavy on dust, you want something like that. Now, let's say you want to now use a material that is a bit more, that takes the light, create a little less glare, and let some light pass through, but not as scattered, not as strong, not as direct. Well, then you're going to go with something that is a bit more what we call a diffuser. So it's a bit milky. It's going to take the light, it's going to break it apart, and the first thing you're going to do is that you're going to be able to take any source, stick it in the box, and then break it so that it's nice and even. You won't have sharp shadow. You won't have you don't have any glare. It becomes, the whole thing becomes bright, but it's not as glary as watching an LED chip in your eyes. And then also, what's going to happen is that you're going to have a beautiful distribution. Beautiful distribution can be done with clear lens too, but you need to have an optical around, and that's a little bit further. We're going to explore that. But let's talk about basic material. So we have a clear, we have a little white, diffuser, so that our source become less visible, more comfortable, and it has less shadow, because it's a softer light. Both of these fixtures, you have some very good control. I mean, You can have different thickness, which will give you different resistance to the light. The thicker you go, the more refraction, and the more it will absorb light. If it's in an area where there's risk of impact, you will want to have something that's a bit more thick. If it's in an area where it's purely decorative, you may not need it. It's just so that you can protect the fixtures. So again, once you have an idea of what you want to light, what you want to do with the light, and where you want to put it, now you start to think, okay, how is the light going to behave? Now let's talk about something that doesn't let any light go through, okay, like opaque material. So now opaque material, we're going to use this mostly as a support, right? Because we're going to build something that holds our source. It's going to be helping us to control the direction of the light. Think of a cylinder on a track. The light's inside, the cylinder direct the light in one direction. So that it is a cylinder, or it is a vase, or it is a ball, or it is an arm, or it is whatever it is, it will give us an opportunity to control our light in one direction. And why do I say that? Because you're not going to see the light's going to be inside, and whatever the casing is, it's going to open to something, going to open to an area. And what it's going to do is that it's going to block all the unwanted light. So everything that's not in that cylinder, it's not going to be seen. It's not going to radiate. It's not going to emit any light, any glow, nothing. You're just going to have what's in that form. That's a square, triangle, no matter what, and the light that's coming out. And also what it's going to do is that's going to help you to define the opening. So you can have a triangle in one, a round in the others, a square in the others, a star. You can have any opening size and shape that you want, and that's going to define the light, the way the light goes. Doesn't mean it's going to define the pattern, but it's going to define how the light comes out. Because to have a pattern, a very sharp pattern, which is a star or a very sharp circle or a triangle, you need to have a special arrangement of optical component in such a position to be in a special shape, to have that shape, projected precisely on that surface. So, and that's what we see as an example, so that you understand. When we go to theater, we see these big lights. They're massive, and they have little things on the side, and there's a little bracket, and they light up, and so those lights have a series of optical lenses. They have a series of shutters, and they have different accessory to control the shape of the light. And then you can put a color. Nowadays with LED engine, we don't need to put a color, but you can put different patterns, and it will project the patterns on the stage, on the wall, on the ceiling perfectly. So, but this is a lot of technology encased in a box, and we'll talk about this when we're getting there. But this is something that you can do. So controlling the beam, the shape of the beam, the general shape, that helps you to create contrast. Because if I light up a wall with a circle, everything that's not in the circle now becomes dark, right? If I have a general diffuse and this light goes everywhere, now the contrast is not really existing in the space. You see the difference? So by creating a shape with the 3D printer, having a light inside, And controlling that light into an area will give us this big contrast. And also what it's going to do is that it's going to eliminate the glare. Of course, if I light it in my face, I'm not going to see anything. And that's why sometimes when you go to a rock concert, uh, or if you've ever been on a stage, you have all those lights in your eyes. And what we do when you do concert lighting is that we put little lights in front of the stage, lighting up the crowd. They're called blinders. They're not really blinders. What they are is that they cut the ratio of contrast so that the person on the stage can see the audience. And normally they're not light up all the time. They'll come up when at the end of a song where they want to see the people clapping and this and that. So again, there's a lot of terminology, there's a lot of techniques, there's a lot of things we do. And if you start observing how people play with light, work with light, use light in different area, you'll start to think differently on how you want to use the light yourself. That you're doing architecture, that you're doing fixture design, that you're doing a team environment, that you're doing, whatever. It doesn't matter. Light is a tool. You have to use it and you have to understand it, and then you can start experimenting. And it's not all going to come in one go. Every day you add new tools to your toolbox. And then one day you can come in and, they can come out and you can start spitting stuff out and it just makes sense. At the beginning, you listen and you look. So let's talk about surface. Again, if I take my example that I gave you earlier of a cylinder on a track lighting up an art piece, right? We got the attention on the art piece. Now, if I take the same cylinders and I make it in a translucent, not transparent, but translucent, now suddenly I have the contrast, but I also have something up there that is attracting my attention. Suddenly I can see the fixtures because the fixture come part of the lighting creation that I'm doing. Now this fixture, I can start to work and give it some texture. I can work and give it different shape. I can work and give it different layers. I can work and insert some different material in it, translucent, opaque, translucent, opaque. I can create and I can modelize this shape now to give. I can give it a shape, the shape of an airplane. I can give it a shape of a seashell. I can give it any shape I want. So now I have both items. I have whatever is there and whatever is there. And you have to think that sometimes it's important. Okay? Sometimes the art piece or the subject you want to light is very important and you want zero distraction. Sometimes it hits a hole. Let me give you an example. And this is just a creation. If you have some beautiful seawall form on the wall, and then suddenly to light it up, you can have the shape of a fish, your little lights in translucent. So you have these beautiful little fish that are all lined up and that are projecting light on that seawall. So now we're using the lighting fixture to enhance or to communicate the wavy and the water pattern on the wall. And I mean, from there, I think you have enough imagination. And if you don't, start reading and looking at books. But you can see that how we can use design and elements to merge and to tell a story. Sometimes we just want to give it a rough surface. Sometimes we want to more define, maybe give some line because we want it a modern look. Sometimes we can create these little patterns because we want to make it, futuristic look, or we want to create them in a vintage envelope because we want to give that rustic look. So the container, the light, the light that support the fixture that support the light source now becomes part of the story. In the past, it was very complicated because we had to do toolings, we had to do special mold, we had to do special injection, and a lot of money would have been invest before we see one product. Nowadays, we can do it in no time. So again, the more creative we are, the more option we have in 3D printing with the different material. And I'm saying this, and I haven't even started saying that now we can merge different material together. You can also manufacture different accessory. You can have all kinds of different color in the same fixtures and the same print. So as we will see, the layers and the layer are more are easy to integrate and more accessible than before. Before we wanted to integrate a nice little blue line around the fixture to give it, let's say, a Tron look. Well, it was complicated. We had to manufacture two pieces of metal, a piece of plastic that go, assemble it, find a way to that it all together. Now we can do the same fixtures in one print, and even more. I can even go vertical. I can go, and it's all print and all tied in together. So there's less and less difficulties for integration, and it all embody perfectly and seamlessly. This is the most important thing, because we all had experience where we had one part manufactured there, one part manufactured there. We tried to put it together, and yeah, oh, we have to file this, we have to, shave this, sand this, do that. Now it's all done in one go. So the possibilities are getting awesome. I just spoke about finish. We have less sanding, we have less coating, we have less polishing, because depending on the speed and the way we set up our little printer, we can have something that is perfectly finished. I didn't know that, but I learned it over time. We can have something that has a beautiful wood texture. We can have something that has some very clean lines, like a machine piece of aluminum. So that we use, and all of this can be done with transparent, can be done with translucent, can be done with opaque. It doesn't matter the material. Once you start understanding and start experimenting and start observing, you can command and you can have something that will deliver that. So the finished product that would take maybe 10 people is done with one machine. And it's amazing because the material are getting smarter, the machines are getting also smarter, and for me, part of my team, I have dedicated team that does all my 3D and my 3D printing. They are amazing. They have all kinds of ideas. They come, and I never stop them. Show me stuff. Every week we have this brainstorming session. They come in with piece they did. Whenever my machine are downtime, they're invited to create stuff and experiment on me, because I want to know. I want to know how I can get better, how I can do better product. And again, these kids, they are amazing. They have, yeah, they're and in exchange, I show them lighting. I teach them how to sell. I teach them how to present the product. It's funny because I was we onboard some new clients last month, and uh, and and I came to the office and I showed my guys. I said, okay, let me show you the presentation that I'm going to present, and they were totally blown away. They said, well, we never seen this. And I said, the reason why I'm sharing with you, and one of the kids said, well, you're not afraid that we're gonna steal your client. Well, first of all, this is a different subject. Ethics is a different subject. But what I want you to understand is the impact that you have and how a whole team can bring something together. Not just me. I'm not a one-man show. I mean, I can't. There's so much stuff out there. I can't. So the more I can delegate, the more I can have other people understand, the more I have my employee and people I work with come to me with sellable idea. I said, it's very nice that you invent something that you dreamed of and maybe you think it's going to catch up. But if you have something that responds to a real need, it's way easier to sell. It's way easier to make a client understand and go and show, hey, I have this. Do you need this? Oh, yes, I need this. Finally, somebody thought about it. This exchange, then you become with a solution provider. And this is the brand that I want to be, and I always been, is that I never went to clients and say, oh my God, no. I always come and say, what do you need? And here's a solution. Maybe it's not the best solution, but the more I understand about your problem, the better solution I can present you. And trust me, when I present you a solution, it's not something I pick out of a hat. It's something that I try. I try on my own time, on my own dime, at my house or on one of my jobs or at, in my garage. And when I bring it to you, I know I can bring it. I have a team. I have people. It's a vetted process. So as a manufacturer now, how do we choose the right material? First of all, there is already standard. And there's different phase of a project. When I do prototype, I don't use expensive material. I use the cheapest material I can because what I need is a concept and I need it quickly and I don't want to spend money. So I don't care about the color. I don't care about any proprietary or property of that material. I'm just doing just something based physical so I can see what I want. Do I want it bigger, longer, stronger, fatter, whatever, right? Same thing with thickness. I don't care about thickness. When I'm working with mass and volume, I want to see what it is. I am pretty well. I'm pretty good in 3D vision, but when I talk to a designer, an architect, a client, or any other member of my team, I want us to agree on the same subject. I show something, and I said, "This is my idea." Now, if you want it bigger, how big? 2 times, 3 times, 4 times, 10 times? I don't care. I just want to know. Now, if we make it 10 times, that means that this is going to be 10 times bigger, and this is da-da-dee-da-da-da-do. So when I go over all the details and I note them, when we go back to production, we save a lot of time. And then I come up with the product, again, with cheap material. And normally that's the last chance you have. I said, I'll make a prototype. I come in with my own idea. Here it is. Then I ask your opinion, and this is the last change. This is your last opportunity you have to change. If you say, I want this, I want that, good, I don't care. Oh, go back to the small one? Fine, no problem. After that, I come with the product with the real material. Now, if you want to change that, now we go into change order. So I developed a technique that is very, very well liked by my employee, by my clients, by design team, and it makes sense because I'm not going to print endless amount of prototype because somebody. The other thing I do is I take a Sharpie and I have them sign on the directly on the 3D parts, and normally that wake them up. They're like, oh my god, okay, yeah, this is real. I'm not saying that this is the perfect system, and I know that as material improve, I will get better, at it. I will get faster. I will get more elaborate and sophisticated. But I think if you're starting in the lighting industry and then 3D printing, and you understand the basic of what the light source does, how the fixtures, and then now you're on the manufacturing side and you work with that, you'll be able to create products that are going to be way more performant than you think, because you can come to a finished product in no time. You can come to different material in no time. You can experiment. Once you have a 3D shape, you can just change the material. And also, you'll create a certain consistency and a flowing dialogue, which is very important when you start talking about manufacturing. Because sometimes what I do is I pull out a couple prototype and I said, well, this is what we can do. This is, I think, what you want. This is what we did for such and such. This is another test, and then the solution is maybe an hybrid of all this. Maybe it's a mix of all of that. But the most important thing is that how does the light behave before I start anything? Before I start pushing any button on, I know how the light that's coming out of there is going to be. And that's the most important thing to understand. The shape, the size, the material, the color, the all of that is accessory to what do you want the source to do. And I will not impinge more than that, because I don't care who says what. I will challenge anybody. If you don't do that, you don't know what you're doing. You don't know. Somebody was telling me, "Oh my God, all I want is sharp edge." Good, that's your opinion. But what is sharp edge? It's directional light that's hitting something. Now, I you want to achieve that? I can achieve it, but it's going to require a lot of work, a lot of hardware. What is it that you want with these sharp edge? I don't know, right? Why do you want sharp edge? That's your prerogative, not mine. I can do it, but is it really serve the purpose? Is that very, very, very important that you cannot, live without? Maybe, and that's why I'm not judging. I'm not judging anything. When my client says this is what I want, Bob, good. And then I start asking questions and digging and looking and demonstrating what's the difference. Then they start to understand. Oh, maybe that was wrong data. Maybe that was somebody else's idea. And you're right. It doesn't look that good, or it is looking better. I and I'm not there to stop anything. That's the thing. My favorite answer is yes. Let's do it. Let's do it, because I know I want to get better. I want to grow. I want to create new stuff. So by saying yes, I open the invitation. I open the door to learn something new. If I say, "Oh no, this is all the only way I've been doing this for 40 years, and that's the only," no, this is it. Like I'm closing myself. Thank you for being there. So, just in closing, 3D printing, um, 3D printing lighting, the material is not a finish. The material is not important. What's important is the behavior of the light. And don't don't be fooled. And don't let that stop you. As long as people talk how the light behave, they can do whatever finish, they can do whatever shape, they can do whatever. But if they can't explain the behavior of light, you will never get what you want. So thank you very much. See you tomorrow. Tomorrow we're going to talk about design, and I have something amazing about design to tell you about. And